public doesn't understand, and I didn't understand at the time, how hard it is to make a drug. I'm an early riser, and most people aren't, and that's worked really well for me. So I get a lot of work done before most people even arrive at work. So Stokes he's a singular individual, but when he latches onto something, it's like a dog with a bone. And we realize that, whoa, there's a tremendous untapped potential of chemistry that we didn't explore. The thing that's really important is to learn that most of what you do in a lab is fail. The organisms that typically make antibiotics have genetic programs to produce maybe 20 to 40 different compounds, all of which are bioactive.
How bad is the current AMR situation globally right now?
Well, it's really bad. Let's put it that way. And it's only getting worse. All of this started to happen in early 2000s. Peter George, Kelton, David Braley, they invested and we took full advantage of it. And that was absolutely game-changing. The echoes of that continue to this day. The thing about antibiotics is that everyone needs to realize is antibiotics are different than any other drug. And the reason why they're different is because the minute you start using it, the clock starts ticking.
Welcome to the Sinclair Podcast, where we share real-world experiences, wisdom, and the honest struggles of entrepreneurs to help you navigate and scale your business with confidence.
Hey everyone, I got a huge favor to ask. If you're getting value from this podcast, tap that 5-star rating on Spotify or Apple. The more we grow, the more leaders and entrepreneurs we can help. Thank you for being a part of this. Now let's get started. Gerry, thank you so much for making the time today to come on the podcast. I really appreciate it.
Oh, it's my pleasure, Chris. Thanks for having me.
Hey, it's awesome. We obviously met, well, for those that don't know, through our mutual friend, Mr. John Stokes. You've so kindly been supportive with Stoke Bio from the early days on, and also just being such a huge impact to John in his life and his career. So I thank you for that, and I'm honored to have the pleasure of getting to know you a little bit more now.
That's a lot of fun. Stokes is a super cool guy, so I'm delighted that we've got him back here in Canada.
I always say he broke the mold.
Yeah, he's N of one, that's for sure.
Yeah, the bad boy of AMR. So, well, let me start. I mean, Gerry, your CV, your resume, it is literally a page long, and I wouldn't do you credit by reading through one by one. So I'm going to make sure that that'll be included in the show notes. But why don't I start with the impact? You've had this incredible impact on antibiotic research, the leadership in academia. When you look back at the career you've had in so many different areas, what's the proudest moment you've had so far?
I mean, the thing that I don't know about a moment, but certainly the thing that I'm most proud of is, and the thing that lingers longest, or will have the longest life, is just the people that I've trained. Right, I've been involved. There's been graduate students, postdocs, about 100 people through the lab over the last 30 years. Dozens
Wow.
of undergraduate students who've done projects and worked in the summer and done senior research theses, and there's that network, that sort of family now of people that are connected to the lab. I think that's the legacy of the lab, of the Wright lab. It's those people who have gone off to do great things, and not just in science but in all sorts of other areas, which is, I think, again, another big, I know when I try to train people, I don't necessarily, we're training them for science, but the skills are so portable, right, that people have gone off to do all sorts of things, and from running biotech companies to education to marketing to government, all sorts of remarkable places that I certainly didn't train them for, but I hope that their time in the lab has helped prepare them for those careers. So that's the thing that I'm most proud of, for sure.
For sure, and knowing that you had that impact, and I got to assume it's just so rewarding when those individuals reach out along the way, along their milestones, and you being I don't even want to say small, you being a great part of that in their journey.
Yeah, it's great fun, and I can bask in their success. So it's wonderful to have this connection to people.
It's great. What got you into science in the first place, Gerry?
That's a good question. I honestly, I was someone asked me this question the other day, and I don't know. I think it's just been, you know, I might be where I grew up. I grew up in Northern Ontario. I grew up in North Bay, Ontario, but not even in the city, on the outskirts of the city. So not a lot of neighbors. And our backyard went
Yeah, for those that
probably
don't know, like 4 hours north of Toronto, plus like not much
right.
else around there.
Uh, yeah, and it was like our backyard went on, probably all the way to Lake Superior. Like it just there was no there's you're in the woods up there, and so I spent a lot of time in those environments, and I think I just got an affinity for how the world, how it all connects together, the natural world and stuff. And I think that helped spur this interest in science. It's just sort of always been there. It's hard to pinpoint a specific incidents that got it into it, but I think sometimes that's part of it. That it was just where I grew up that inspired me to think about the world and the natural world.
Do you have connections still in North Bay?
Some some relatives that are still there. Most of all my friends and peers at the time out of high school, we all sort of eventually left.
Dispersed, yeah.
Yeah, I mean I always say it was a great place to grow up. Probably for someone who wants to have a career in science, it might not be the best place to lay down roots over the long term. Um, but it's a great place. We go back every once in a while to see it. Different a different world up there for sure.
Yeah, I could appreciate it. Slightly different, but I'm an Owen Sound boy, north.
Yeah,
Somewhat northern, a little bit more west, but yeah,
got it.
it's beautiful being out of the city for sure.
Yeah, yeah, for sure.
So back to mentorship, you've mentored so many people over the years, and I want to go back and talk about John Stokes because you've seen him and his career evolve and the work his immersion in AI machine learning and now using that as a tool. What's it like been watching him specifically as he's evolved?
So Stokes is as I said at the beginning, he's an N of one. He's a singular individual. So I was on his PhD. Uh, every PhD student has a committee consisting of the principal investigator who they're working with the most closely, and some colleagues who are generally working in similar areas that can help guide the project and the student as they go along. So I I was part of that when he was in Eric Brown's lab, and I got to see him like from the beginning. And he's one of these guys, as you know, he's a deep thinker, and
Extremely.
he's always been this way. But when he latches on to something, it's like a dog with a bone. It's a really and so these are like qualities you can't train qualities like that. They're innate,
Yeah.
right? You have to have the this ability to focus on what you're doing, but also the ambition to, once you see something happen, and to know that that's useful to pursue and to pursue it with just a tremendous amount of energy. And that's the thing that Stokes had as a graduate student, and a tremendously cool imagination. That's the other thing that's part of it. And again, untrainable, right? Like he would get these ideas and he'd say, John, where did that come from? And, you try and talk him out of it. And I'm sure sometimes you could, and most times you couldn't. And that's a good thing because he was right at the coalface. He knew what he was doing. So, uh, it was really cool to see him then when he transitioned out of the lab and went down to MIT and started to work, to make this connection between what he had learned in Eric's lab, which was, and Eric's lab is really such a great training environment for thinking about, systems biology and application to infectious disease and the power of genetics to be able to move things forward. Like it's a really wonderful training environment that he was in. And then take all that knowledge and then now marry it to AI, which I didn't see coming. right? I did not see Stokes going down there to become a computer guy.
And I don't think he
Um,
did either, right? It was sort of by chance and being immersed at the right time with the right group.
well, and that's what I mean. That's Stokes, right? Like he had the imagination to be able to say, "Oh, I see. It's outside of my comfort zone, but that's okay. I can learn that." Right? And I know smart people who will help move this forward with me and make that connection. I mean, that's the thing that is continues to impress me about John. Like he's brought that to his own team and into Stokes Bio. This idea of, I don't know everything, but I can help connect things together and then do things in a different way that people haven't done before, right? So he's a singular dude. And of course, he's got the whole hipster mentality and look that
I
is
just
that
keep
is
saying he broke the mold, right?
yeah, he
He
is.
doesn't look like a traditional scientist and at all.
No. And this is the thing, people ask me about, academia sometimes. This is why the academia is so cool. Because you can get people like if you're trying to take Stokes and put him in a team in, I don't know, not to pick on anybody, but Pfizer, like a corporate kind of environment where people have to behave in a certain way with the layers of responsibilities. You don't get the best out of a guy like Stokes that way. But in
No,
an
no,
academic
no, no.
environment where creativity is encouraged, where you get rewarded for taking risks, then he's perfectly suited for it. And that's the best part of being in an academic environment, honestly. I often joke sometimes, and especially when I was in positions of leadership at the university, is that it's a lot of these people in another context would probably be homeless because they don't know how to behave,
That's right.
but they're
Yeah, they would
brilliant.
be walked out the door.
Yeah, they'd be brilliant, right? And that's why it's so important to have university settings and to support people who want to take risks and want to do different things, and you don't stifle that creativity where in an environment that is otherwise conformist. So so I love having guys like Stokes around. It's adds so much diversity to the team. It's great.
Absolutely. You mentioned leadership roles, and I know you've had so many. But what's your leadership style, if you had to describe it, Jerry?
Really have a style. I mean, I think I've joked before that I have and this is going to date me tremendously, Chris. And you might not get this reference, but I call it the Meadowlark Lemon style. So
No, I
Meadowlark
don't get it.
Lemon,
Sorry. Do explain though.
yeah. I remember when I was a kid up in North Bay, the Harlem Globetrotters came to town,
Yeah,
and I got to see them at North Bay Memorial Gardens. It was the coolest thing.
that's
And there
cool.
was this guy, Meadowlark Lemon, who, and you can look him up. He's a remarkable dude.
I
There's
will.
YouTube videos of him and stuff. He would stand at the top of the key, and basically his job was to pass the ball and make everyone else look good, right? And I like to pattern myself after Meadowlark Lemon. Like he's an unselfish sort of enabler of people on the team. And that might be a little bit grandiose, and thinking on my part, but it's something I aspire to. Let's put it that way. So I don't think it's an official leadership style. I don't know if you look in a leadership textbook somewhere that the Meadowlark Lemon formula
It's
works.
officially been added. We're putting it in. I
But
love it.
it's sort of been the way that I've viewed the what I can do, and it gets back to our discussion about in academia. In academia, you have a lot of very strong personalities who are we hire people because they can because of that. We don't hire them to be team players. We hire them to be individuals who will start their own research programs and make their way through the world. So you need to be able to take full advantage of those qualities that you hired them in, and help them thrive. And that's, I think, the job of an academic leader, really to do that.
Has any of your style changed over time, just with experience or through different roles?
Absolutely. When I started the lab, you know, like all of us, and it continues to this day. It was, I was convinced they had made a mistake, that I had snuck in the door somehow, and they were going to find me out.
Yeah.
And so, you know, at that point, of course, I was leading my lab, a small group of young people, and I think I tended to be a bit more dictatorial and autocratic. We're on a timeline. The tenure clock is going this direction. We've got to get stuff done you have to work together. And I did try. I'm sure you'll have to go back and ask the folks in the lab, but I was much more directive about what we should be doing, and what everyone was going to do. And it took some time to realize that you get the best out of people by, passing them the ball as much as possible, like Metal Lark 11, and
Back to
giving
your
them
reference.
the
Yeah.
opportunity to do their own thing. So and take full advantage of their skills, because everyone is different. That's the other thing I learned. Uh, so so I think, yeah, it had changed a lot, and it comes with age too. You get more comfortable uh, with yourself, and get better at understanding where people's strengths are and trying to play to those.
Yeah, I was going to ask if it was experience or wisdom through age, or probably a bit of both.
Yeah, it's like anything. You try things, and when they don't work, you need to pivot, and so you make a lot of mistakes along the way, and you hope that they're not uh, too bad at the end of it. You haven't damaged people
That's right.
too much.
That's right. Yeah. Got to learn along the way, though.
Yeah,
Let's switch to McMaster. I mean, McMaster has, and I'll say Hamilton area has this incredible spotlight, in a wonderful way, of brilliance and success, and like so many great things coming out of the area. Can you sort of draw a line back to, a moment in time, or a series of events that happened that has really caused that, energy and excitement and spotlight for Mac?
yeah. That I mean, so I've been at McMaster. I got there in the January of 1993, so I've been there for a while. When I got to McMaster, it was especially in our field, the infectious disease. It just wasn't on the map at all. Um, I got there, it was, and I don't want to use the word sleepy, but it was a very sort of traditional kind of university. The odd part was the medical school, of course. The medical school was started in the late 1960s. Honestly, it sounds to me, I mean, I don't want to characterize this incorrectly, but by a bunch of hippies who who were not going to conform to the man, and they decided to start a medical school based on problem-based learning and not didactic lectures. And so the students didn't sit in classes and take notes. Rather, they worked in groups with mentors to be able to understand problems and suss them out. I mean, that was radical.
That's
Um,
awesome. I didn't know that.
yeah, it's a crazy. And I think back to the, just not to go up the well or go off too much on a tangent, the courage it took to do that. It might have been just like a moment in time. Like I said, that's why I make the joke about the hippies, because the whole counterculture was happening at the same time, right?
That's
And
right. Good time
and
for
I'm
it.
old enough to have remember that as a kid, seeing all this stuff happening in the world. But they really took education in a completely different way. So we're going to teach doctors how to be doctors, not by getting them to write tests and learn from big books, by people, standing in front of the classroom and shouting at them for 40 minutes. We're going to get them to roll up their sleeves and do the hard work of learning together. Really impressive. Um, so there was that element of risk taking at McMaster, sort of baked into the programming in the medical school. But when I got there, it was, the Department of Biochemistry was pretty common. It was one of these. departments. I call them Noah's Ark departments. There's two of everything, and it's generally built up that way because of the need for teaching, right? You need two protein people and two DNA people and two,
Sort of fit a
membrane
standard
people.
model.
Yeah, and it's works. Um, but the game changing thing that happened was, in my view, having lived through it, was when Peter George became the president in the late 1990s. Excuse me, and then John Kelton became the dean of the medical school in 2001. That's actually when he became the dean, and I became the chair of biochemistry at a ridiculously young age. Um,
How old are you?
37
That's amazing.
is crazy. But so those two folks together just basically set their goals on being the best that they could, and that inspired, I think, some philanthropists to be able to underwrite that, and that really changed that being able to get that money from and that support from some of the wealthiest people, mostly in the Hamilton area, to take the McMaster to the next level was game changing. And that's when we were able to build out of the much larger infectious disease research team. It's happened exactly too at the same time when, and a big shout out to them. I'm not a political guy at all, but the Jean Chrétien liberals invested in research and development in a way that wasn't seen before that and hasn't been seen since, which is quite unfortunate. They started the Canada Research Chairs. They started the Canadian Institutes for Health Research, the Canadian Foundation for Innovation. The Canadian Foundation for Innovation created the opportunity for us to get all of the infrastructure. Like, so Chris, you've probably seen our high throughput screening lab and
It's
all the
so
stuff that helps
impressive.
Stokes do his
Yeah.
thing. That
I
came
walked
from
through and go, how much is that thing? How much is that?
yeah.
It's like 20 million, 10 million, 5 million, 20 million.
I like that actually when we have politician visitors, I always tell them, that machine costs $1.2 million, um, and here's what it does. And it's important to have that machine, and so it's important to get them to continue to support fundamental research.
Yeah,
But
absolutely.
uh, all of this started to happen in the early 2000s, right? So Peter George, Kelton, Mike DeGroot, David Braley, they invested, and we took full advantage of it. And that was the thing. That was the turning point, especially in our field. Um, and enabled us to attract the best students and postdocs and the best guys like Stokes. It enabled us to play on an international field, and that was absolutely game changing. And the echoes of that continue to this day.
Yeah, it's just the perfect recipe of those, a few really good things, the right leadership vision, funding, government support, private support. That's amazing, and it
Yeah.
continues to be a leader in so many different areas now. So it's been, again, fun to watch from outside looking in.
Yeah, and again, it's to your point about the Hamilton area. I mean, the people who invested big in these philanthropists were Hamilton. Lived in Hamilton. They lived their lives here. They made their fortunes here. And it was really great to see them reinvest in the area.
That's awesome. I want to switch over to AMR, so antimicrobial resistance. For those that don't know what it is, but let's have an honest chat about this. How bad is the current AMR situation globally right now?
It's really bad. Let's put it that way, and it's only getting worse. The thing about antibiotics is that everyone needs to realize, if they're not familiar with it, is antibiotics are different than any other drug, right? So and the reason why they're different is because the minute you start using it, the clock starts ticking on how long be able to use it. And the reason for that is just the evolution of resistance. So bacteria um, have very short generation times, on the order of minutes to hours. So they can divide, and then they can divide, and then they can divide. Our generation time is decades, right? Like we can't sample a lot of genetic
No.
diversity on a time scale that you would think that bacteria can. So they divide very rapidly, and just through Darwinian natural selection, survival of the fittest, um, the ones that can survive are the ones that win. And so antibiotics provide this tremendous selective pressure in bacteria to try and survive. Um, the good news is that it's not instantaneous. So you get a lot of lifetime out of most of the antibiotics that come to market. But eventually, you know, the odds of them working 100%, which is what you want, starts to diminish. And that's where we're at right now. Where there's no the antibiotic that we have for which there is not a significant resistance population on the planet. Um, it's causing now people to die from infections that otherwise we would have cured easily 10 years ago. So, there's been a recent study in the Lancet that said that there's about uh, 4.5 million people a year that are dying as a result of this. And it's only going, you know, this way. So it's only going to increase. And just imagine, so those are people that otherwise, 10 years ago, say, would have been fine. It's because the drugs are failing.
Wow.
And and so that's fine. So we've always known that antibiotics are different like this. Like you'll never become resistant to your blood pressure medicine. You know what I'm saying? Or your cholesterol lowering drugs or your Ozempic or whatever it is.
Yeah.
Um, but antibiotics, that's what I mean. They're totally different. So there has to be a continuous supply of new ones. And for all sorts of complicated reasons, the tap for that new supply had got turned off about 25 years ago. And as a result, we have this growing gap, more and more resistant organisms, less and less new drugs coming forward to be able to help support physicians and healthcare providers to solve those problems. And so then you end up with what's the situation we're in today, was this very large gap between a clinical need that is only going to grow over time and a lack of new drugs. And then remembering, of course, that it takes a decade from a discovery to that you make in the lab to get it into people eventually. Um, so that lag is in there as well. So we have a needs gap, and then there's a time lag. Even if today you turned on the tap and said we're going to try and solve this problem on a global scale, it will take a long time to fill in the gap so that we have a diverse portfolio of new drugs out there. So
Do you
it's
ever
not
lose
good,
sleep over
Chris.
this? Knowing no, and I think again knowing enough about the stats from from John and Stoke Bio and from the research and what I've read, that's a scary number. You're saying 4.5. That's increasing. That could increase exponentially. Do you ever lose sleep? Do you think about this often? I mean, this is a not spoken enough about
Yeah.
global issue that's not really become an issue that's talked about.
Do I lose sleep about it? No, I don't lose sleep about it, but I dedicated my life to trying to solve it. So, and the people in our team and the people at our research institute, the Groot Institute for Infectious Disease Research at McMaster, that's the reason why we pulled this team together from all over the place to be able to solve this problem. So, you know, it's a big deal. I mean, and when I've talked about this before when I give public talks. I mean, I've experienced this myself, right? Where I've had an infection, a bloodstream infection that was drug resistant. And so I know what it's like to take an antibiotic thinking that you're going to get better and you don't,
You don't.
right? And the good news is that in my case, because I had a salmonella bloodstream infection from food poisoning, it's about 10 and 15 years ago. it was resistant to the first line antibiotics that they give you for this, but it was sensitive to to a more, you know, difficult to administer because you have to administer it through IV as opposed to orally drug.
Mm-hmm.
But I know what it's like to sit in a chair, feeling like absolute crap because you got these bugs growing in you, and then half an hour later feeling great because the antibiotics just basically work like that. So, on a personal basis, I know what it's like. And then, but and then you think to yourself, well, what if you're one of those people in an ICU, for example, where the bug is not responsive to that second drug or that third drug or any drugs that we have. That's when you really start to think about the implications of this. So as a result, we try hard in the lab to try and solve these problems. You know, the it's not the bigger problem of securing resources for development of new drugs is kind of outside the remit of what we can actually do as individuals. But certainly we can help uh, do what we do best, which is discover new compounds, just like Stokes is trying to do.
Absolutely. On that note, I literally read an article on LinkedIn this morning. I mean, congratulations to you and your team for an incredible new discovery, and again, the starting point of hopefully something that is going to save some lives. Can you share some insights about that?
Yeah, sure. I'd be happy to. So yesterday we published our discovery of an antibiotic that we call lariacidin. It's a small peptide. It's called a part of a group of compounds called lacopeptides. They're named lacopeptides because they have the shape of a lasso, like when you catch cows. So it's like a circle, and
Interesting.
you thread one end of the peptide into it. So that gives them this very stable structure and a unique shape. And we discovered it actually from a soil sample from an organism that makes the so it. Sorry, I should back up. We discovered this antibiotic. It's being produced by a soil bacterium, and we got the soil from a longtime technician in the lab who had brought soil in from her backyard in
In
Hamilton.
Hamilton, we're talking
So
like there's no
yeah,
more homegrown than that, Gerry. That's awesome.
it's pretty cool. Yeah, and
Yeah, really cool.
yeah, so it looks, it's one of these fun discoveries. It's new structure, new mode of action. It works by inhibiting protein synthesis. It is not susceptible to existing resistance. It has a low propensity to select for resistance itself. There's no such thing as an irresistible antibiotic, but there's some that are harder to get resistance to, and this is one of them, I think. It works in an animal model of infection. So all of the things that you'd like to be able to see, check the boxes about, is this something that might be able to have a life outside of the lab, are checked. So you never know what tomorrow will come. But we're trying very hard to take this discovery and work with it to try and move it forward into further preclinical development. And fingers crossed if we get further than that.
That's awesome. Congrats to you and your team. That's really exciting, Gerry.
Cool. Thanks.
In addition to that, what else are you excited about that you're seeing as far as discoveries and developments in the industry?
It's an incredibly exciting time to be in this field, in the antibiotic discovery field, to be honest. It's really so there's a lot of different things that come together to make things really inspiring and exciting. One of which, of course, is what you're well familiar with, Chris, is AI. Artificial intelligence strategies to be able to explore, new chemistry and tell us, where to go in terms of identifying new chemical structures, I think is breathtakingly exciting. And I'm really excited that we have that capacity in our team now with John. And so that's a really big, a fun thing to do. The thing that we focus on in the lab is natural products produced by microbes like this one that I just mentioned. And there, there's always been this. That's where we have most of our antibiotics come from, are these soil microorganisms. So everyone knows the story of penicillin and the mold on a petri dish and all
Yeah,
the
left
all
and
the
later found.
yeah, exactly, and all the sort of other, or most of the other antibiotics that we use today have come from those sources. But then we stopped finding new things, and so people sort of moved away from these sources. But now with genome sequencing, we can go back and look at the organisms, and we realize that, whoa, there's a tremendous untapped potential of chemistry that we didn't explore using the sort of traditional method, which was, grow up a cell, do an extract, and then see if that extract has something that kills. Um, it turns out that the organisms that typically make antibiotics have genetic programs to produce maybe 20 to 40 different compounds, all of which are bioactive in some course. So that's been an exciting thing. And now if you now layer on these new technologies in synthetic biology, where you can easily, you can go in and manipulate those genes and maybe move them into other sources and try to overcome some of the challenges of working with the natural products that come from microbes, is really game changing as well. So you have these new technologies, or what I call 21st century technologies in synthetic biology and artificial intelligence. So these technologies are coming to bear in this field now, and others too. I mean, the application is not just for antibiotics, infectious disease. You can see this working for cancer. You can see it working for metabolic diseases. I think the sky is the limit. So it's in a very, very exciting time to be in the field. So it'd be a great time to be a PhD student
Yeah,
again,
absolutely.
as opposed to an old crusty guy like me.
Hey, you get to be immersed on. You did it before, and now you're still in it now, which is great.
Yeah.
That's exciting. I want to talk about the venture you were co-founder in, Symbol Therapeutics. How did that start up, and tell me a story through that, the journey of it.
Yeah, that was a fun story. So Simple Therapeutics was founded on a discovery we made in the lab, again from these natural sources. So in this case, we collected a fungus from New Brunswick. One of my graduate students was out camping in one of the national parks there, and she brought a sample home, and we found this fungus, and we were looking in particular for molecules that could reverse antibiotic resistance. In particular, we were looking for molecules that could reverse the activity of a particular class of resistance enzymes called metallo-beta-lactamases, which is a mouthful, but basically, some bacteria produce enzymes that chew up antibiotics. And one of the most important classes of antibiotics that we have, probably responsible for 60% of the antibiotic use, are what we call beta-lactam antibiotics. So penicillins, cephalosporins, and the latest version of those are called carbapenems. So they all share a core beta-lactam structure. So
Okay.
it looks like a square. And so these enzymes basically snip that square open, and then the antibiotics don't work anymore. And so they were becoming an increasing problem. So we thought, well, if we could find a molecule, maybe that nature made, that could block that activity, then our antibiotics would be useful again. So you would imagine packaging that as a combination. And so we did. We identified a molecule. It has a terrible name, so I'll just call it ANA. And ANA was produced by this fungus from New Brunswick, and we we showed, and there was a big paper that came with it, and but we were able to show that it had this really important activity. But then it's like all academics, you end up at this. You write the paper, and then you're like, well, what now? So I was really keen to see if we couldn't actually move this into the clinic somehow. And I was really fortunate at the time to get connected to a remarkable program at the NIH, in particular NIAID, the National Institutes for Allergy and Infectious Disease, that Tony Fauci used to run, if you remember that.
Oh wow,
Um, and they
I
had a
didn't realize that.
program, and it still exists. We'll see if it exists tomorrow, given the crazy times we're in, where they had basically ex pharma people as working on what it's called preclinical services. So they would take the discovery and they would say, well, if we were at Pfizer, this would be the next three things that we would do next. Because didn't know what to do, and so they helped guide the next series of experiments. So for over a year, we worked with that team at the NIH, who helped us basically de-risk this compound AMA as a potential drug candidate. And then I was giving a talk at a national meeting in San Diego, and I was describing the how much work we had done. And a couple of folks from the audience got up and said, "This is amazing. Why don't we start a company on this?" And this was a group of experienced entrepreneurs from Boston, in the Boston biotech area. And so we formed this company called Symbol Therapeutics. And then, eventually what happened is, without getting into too many of the details, like any sort of drug discovery thing, it got sold off to another
Which is
development
very
company.
common, correct? I mean, it's you
Very
get to a certain point, and
absolutely.
either you have to get massive funding or partner up or sell off to someone that has the capabilities to advance it.
That's exactly what happened. Yeah, because the reality is that at the end of the day, the only folks that have the deep enough pockets to be able to do this are big pharma.
Yeah,
And so there's a lot of intermediates throughout and that was a really cool learning experience for me. So I got to see, how do you start a company? How do you try and raise money? How do you get investors excited about it? How do you, you know, advance your assets? What needs to be done next? The amount of work. This is the thing that I think again the public doesn't understand, and I didn't understand at the time. It's how hard it is to make a drug, right? Like to actually make so the discovery part, like the paper we wrote this big paper, it was nice. It was the cover of Nature and all this stuff, all the academic accolades you could want. But then you take it and you gotta beat the bejesus out of this molecule because the key, right, when you're making a drug is it has to be effective, but it has to be safe. And the amount of work you need to do
yeah,
every step of the way. Is it effective? Is it safe? Is it effective? Is it safe with it? And safe with all caps. Um, there's a lot of tricky work that needs to be done. Um, that happens every day in pharmaceutical companies around the world because no one wants to introduce a product that is unsafe, right? And Yeah, so we eventually, and the resources to be able to do that are not insignificant. That's why people say it costs like $1 billion or $2 billion to make a
yeah. I was
drug.
gonna say a couple billion bucks, 10 years, 10, 12 years. I mean, that's
Yeah,
and coming in, very outside, not knowing anything about this, I've learned so much more, and I think just an appreciation for the margins on drugs and the how difficult it is, and like how many million things get a no before anything gets through. To your point, just for safety of people that are taking these drugs.
absolutely. And it's the realm of experts. Like you can't be dabbling in this. Like the people who know this
It's not a
area.
side gig for anyone.
No, like it's in the pharmaceutical companies are full of these people, these with deep expertise, um, in pharmacology, in toxicology, in animal models of infection, in formulation, like all the things that you don't really think about when you make your discovery and you write your paper. So it was a fun ride, and eventually I wasn't part of the next sort of part of the journey of the compound because Sybil had licensed it away. So it's and then eventually, unfortunately, it just the development stopped. So it's one of those many stories of compounds that don't make the distance.
What is it? 1 in 10,000 make it, or something like that.
It sounds about right. It's a tremendous amount of failure, which is it sounds awful, but it's really good because you
Yeah,
don't want to introduce something that's going to have liabilities somewhere down the road, right?
for sure. But what an
And
incredible learning experience for you to go through that.
Yeah, and it actually inspired me to keep thinking about doing it. It's challenging, as you know, Chris, in this area to be trying to think about drug development. Um, but we're very excited about trying to, the next phase of some of the discoveries in the lab to see if we can actually move them along, move them forward. So it's a fun thing, but it's not. It turns out it's not really a part-time gig. Like you got to get people around you who are believe in the direction and believe in what you're doing and who are way smarter than you.
That's
Uh,
the key to leadership, I think, is it not?
yeah, absolutely. I guess so.
No, that's great. Let's talk about Gerry the human. What do you like to do? Either hobbies or other interests. You've obviously dedicated a lot of hours to this piece of your life, but what else interests you?
Well, I'm a big music guy. I play the drums in a cover band.
Come on, that's awesome.
Yeah,
What's the band
um,
called?
it's called the Null Hypothesis,
Love it.
and it's profs and doctors at McMaster. I play with my brother who here. So we have a place on the shores of Lake Huron here, which has turned out to be our home now since COVID. And my brother lives close by, so I like to play with him as well. He's the real musician in the family. He can play, he plays guitar, but he plays keyboards and sings and is a front man. He's one of these guys that I wish I could have the skills that he does. Um, yeah, so that's sort of the main thing that I like to do, and you know, I'm a I like to I'm a big fan of history, and so I spend a lot of time reading those kinds of things, trying to understand why the world is the way it is today.
It's,
And
yes,
so, those are the sort of main things, I guess.
it's awesome. Any habits or routines that have really shaped either career or for you personally that have helped?
Yeah, I think one of the things I realized when I was in grad school, I'm an early riser, and most people aren't.
What time?
And, I'm usually out of bed before 6 o'clock.
Okay,
Um,
good.
and and when I was doing that in graduate school, I realized, in grad school, you're you're transitioning out of undergrad as an undergrad student, so you're basically just still a teenager, which is problematic.
Well,
um, it's
it's definitely a learning experience in those years, right?
Yeah, for sure. You're learning how to be a human,
Yep.
and so most of the time in grad school, people roll in 10 o'clock, 11 o'clock. By then, of course, all the instruments that you want to use are, you're fighting with elbows out to try and get the PCR machine or whatever it is. But if you get there at 6 o'clock in the morning, it's virgin territory. So, um, and that's worked really well for me. So I get a lot of work done even now before most people even arrive at work. And that's been helpful to me. It helps me control the chaos. Um, and 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 give me some breathing space because once people start to arrive, sit in the office now. I don't work in the lab anymore. I haven't for a long time, but uh, then there's demands on your time, and people want to see you and do and what have you, and email starts to become an issue, and you have to deal with all that stuff. So that gives me a good buffer of a couple hours, couple 3 hours I think has been really helpful to me.
Yeah, sacred protected time, right?
Yeah. And the other thing, I'm a big list guy. Like that's how I keep organized in my head. I got a to-do list, and I've been religious about it since high school. And that's my organizing principle. It's only recently have I made it electronic. It's always usually
I
been
was going
on
to ask, are you
pieces of
still,
paper.
manual, write it down, or?
I prefer, and there's something incredibly, like a nice little dopamine pop when you scratch something off on a
Oh
piece of
yeah,
paper, you
yeah.
know. Um, but yeah, I moved it electronically now because so that my assistant, who's amazing, can put things on there as well. So
Yeah.
if I'm relying on a piece of paper, then it's hard for her to find it.
Yeah. One strong wind away from losing the day's
Yeah,
work,
pretty
right?
much. Yeah.
Yeah, exactly. You mentioned history and reading. What's been the most impactful book for you?
Oh gosh. Okay, that's a really good question. Um, I read a book in the early '90s that I didn't expect would change my life, but it kind of did. It's by this guy named Ed Wilson, E.O. Wilson. I don't know if you ever heard of him. He was a biologist at Harvard. His big thing was ants. Um, so he won a Pulitzer Prize by writing this enormous book about ants, which I've never read. Um, but he was like the world's experts in all the various kinds of ants that exist. Um, but he wrote this book called The Diversity of Life that I read every 5 years or so, and it has nothing to do with antibiotics or chemistry or anything like that. But what it does is that it's an effort to try and understand how connected everything in nature is, and because you would go to a lot of this discussion is about the diversity in rainforests and just a square a tree, how much diversity there is on there in terms of insect life and amphibian life and birds up in the top canopy and all this kind of stuff and how all that is connected. And I didn't, I think, appreciate it at the time when I read it. I just thought it was kind of a cool story. It really shaped how I think about evolution, and that thinking has driven how we, big part of the lab is understanding where antibiotic resistance comes from and its natural history. I think that kind of inspired me to think about that, and then those studies inspired our ability to go out and collect organisms from the wild and bring them into the lab. So that we have a collection now of about 12, 13,000 microorganisms that we've collected from around, mostly
It's
from
amazing.
Canada. I don't think I ever would have did that without reading that book. Like I might have, but I think it just helped. It's like an organizing principle for me. Um, I always try and tell the students in my lab they should read this book. I don't think anyone has ever
Yeah, like did
done
it?
it.
Who's read it? You can probably tell who reads it.
Yeah, that's probably true. Yeah, some of them I'm sure have. But one of the sort of the coolest times in my life. So in mid 2000s, the lab published a paper that we called the antibiotic resistome. It was a sample, which was honestly it was inspired, I think, by by reading this book. When I was a postdoc. Um, and the resistome story is all about the fact that resistance is this web of genes that are in the environment, like to just and so we did this study and showed that indeed that's where it comes from. And the paper made a big splash at the time. We were on TV and ended up being in newspapers all around the world.
That's awesome.
And it was my first sort of uh, brush with academic fame.
The
And
unveiling of Gerry Wright. Yeah,
yeah, and I was invited to speak, to be the opening act for Ed Wilson, who was giving the keynote lecture at the American Society for Microbiology conference, I think in 2006 or 2007. It was
wow,
in Toronto.
that's really cool.
So I got to meet him. Such a tremendous guy. Like everything, he was so curious about our work, and I here's this guy. It's like, man, dude, you were people had called him like the best at the time when he's passed away a couple of years ago, but the world's greatest living biologist. So he was a it was cool to have that made that personal connection with him at that meeting.
Yeah, wow, great story. Jerry, how did becoming a husband and then father impact your career and your work?
Oh, it's pivotal, obviously. Um, so I have a tremendous family, really, really supportive. My wife has been unbelievably supportive of all the, like I said, academics are weird people. She's not a weird person. She's a school teacher. Uh,
What a wonderful balance.
so is very tolerant of my eccentricities, I think, and the ambition that we have in the lab to be able to do things, which of course means you
Yeah,
work a
almost
lot.
obsessiveness in a
Yeah,
wonderful way.
yeah. So we don't punch a clock, we don't turn it off when you come home easily. But having Teresa by my side all this time has been game changing. Tremendous support, and the kids have been, you know, kids are they don't think of you as anything special. Let's put it that way. They,
Quite humbling,
uh,
isn't it?
yeah, no, you are. But it was, there was fun when they were small. We were collecting soil microorganisms. They would come out into we'd go home, take them for a hike, and that was their job to go out and find cool things,
Oh, that's
bring them
cool.
back to the lab, and so it was a lot of fun. At then they're now successful people on their own, but uh, you know you can't go through life without having people shape you, and these folks are absolutely vital to where I am at now. There's no question about it.
It's beautiful. Appreciate you sharing. What advice do you give to young researchers getting in the field today?
Yeah, I think it depends on what stage. I think the thing that's really important, especially at the beginning, is to learn that most of what you do in a lab is fail. There's very most of what a scientist does is actually kind of continuously failing and falling down and trying to find your way forward because you're fumbling through. If you're doing anything useful, right? And I mean that not to be um, self-aggrandizing, but if you have to go, you have to take risks, and you have to go. Again, I don't want to use this metaphor too much, but where the puck is going to be, right? You got to move towards that, which means towards the unknown, which means, and if no one's been there before, then you're going to fail constantly, and you have to just learn how to deal with it. And it's funny. I was telling this to one of my students this week who's struggling through yet again things aren't working, and I was like, this business selects out for people who can tolerate this level of defeat, constant defeat, and then
Beat you down.
something happens that, and it could be from the perspective of not of a grand scale, not like a big discovery that you've made, but just like a little something worked, and then that elevates your spirits enough to keep you going. um it's I was watching National Geographic um show the other day about the Shackleton uh expedition to Antarctica. I don't know if you know it. It's
Just a
one of the
little bit.
most it's one of the most remarkable stories of leadership that I've ever seen in my entire life. It's like, and they teach this guy. It was amazing what he did. But the fact that it's like when you're trying to do something like that, it's unknown. How are you going to get across? Their goal was to try and go across the Atlantic, Antarctic continent, which they never actually did. Um, but just advancing a little bit every day, you know, that's kind of what science is. Can you just want to hope that it's slow, incremental, and eventually, if you keep this up, you will be successful. Um, and that's sort of what I tell at least the young people who are starting out to be scientists. And I figure our goal is especially in graduate school, is to teach you how to be a scientist. You know, if when people go young academics, the one thing that I try and tell them to do is get out of your office. You know, the best person in your lab when you start your lab is you in terms of hands, being able to do an experiment in there's no one better than you. Um, and you got to remember that there's not going to be anyone better than you probably for the first 5 years. Um, because the reason why we hired you to be an assistant professor, for example, is because you were successful in the lab. We didn't hire you because you were a successful assistant professor because we didn't know if you could do this job,
Yeah.
right?
Going out on a limb on that, but
So it's a big risk on our part, but you got to get out there. You can't become the hair professor sitting in your office with your patches on your elbows, smoking a pipe, and getting people in the lab to do the stuff for you. You have to be there. You have to lead by example. You have to, show them how to do things properly and not expect them to do things right. I think there's so many distractions for young academics now. I know when I started my lab, there was no internet to speak of. There was no email, right? Everything we did was slower. Uh, to
and more focused.
yeah, there's no distractions. It was one of the things that in some ways it's unfortunate. There's all sorts of potential. Everyone's striving to get money. That's what you got to do as an academic. You have to raise money. Um, but there was only a few ways to get money back when I started. Only a few granting councils. You didn't. It wasn't announcement after announcement where there's, here's an RFA request for applications in this area, this area. It's noisy and distracting. And so I've seen situations where people get into start the new labs and then they get obsessed with all these potential opportunities and they miss the critical mission, which is to train the people in your lab yourself. Um, and that's it's one of the challenges of doing science today.
Yeah, and in an environment that we had talked about earlier is just so difficult. It is in, I think, not just in your industry and academia, but to raise any sort of funding right now it's a difficult period in life.
Yeah, money is always a challenge. It's always going to be a challenge. We're never going to be completely satisfied, which it probably is a good thing. You don't want to fund everything, but right now it seems it's especially dry.
For sure. If you went back 20 years, what advice would you give yourself?
Oh, probably just to relax a bit more.
Chill out a
You
bit.
know, yeah. I mean, I think any normal person has got a lot of imposter syndrome, and
Yep.
I think if you don't, then you're probably a narcissist, and then you're a danger to society.
That's great
And
point. Yeah.
I still have it significantly. I mean, so one of the things I do tell young people is that it doesn't necessarily go away. You just learn how to manage it better. Um, and I think that would be the thing to do. I was wound pretty tight there for a while. Taking some risks by taking some leadership opportunities and growing the lab and doing all that stuff. You know, there's no way of knowing when you're in it if you're going to be successful at it. So it's kind of hard to go back and tell yourself that just to chill out a bit. Um, but yeah, it's the one thing. I spend a lot of time overthinking stuff.
That's great advice, I think, for anyone. We can all probably use a bit of that.
Sure.
My last question for you. If you had a dinner and you could invite any three scientists in the world, dead or alive, who would they be and why?
Uh, so I'd love to have dinner with Ed Wilson again, who we just talked about. And I've had a lot of great mentors in my life. One of them, though, was the guy I did my postdoc with, Chris Walsh. He just recently passed. The guy was
I'm
like
sorry.
absolutely brilliant, um, and had all those things. Like, he was a brilliant scientist, an amazing leader. He was when I was in his lab, he was the president of the Dana Farber Cancer Institute. Um, has a you know a laser beam sort of organizational mind. So, who, interestingly enough, as an undergraduate, worked in Ed Wilson's lab.
Oh, come on. That's
Yeah,
funny.
no, it's an interesting connection, eh?
Yeah, it's for
So I'd
sure.
love to see those guys talking together. And one of my favorite people in the world, these are all dead people now. And for Julian Davies, who died like a month ago, uh, was one of the most remarkable people working in the antibiotic resistance field. Also, an amazing leader. Worked in both the biotech and academic sectors. He was uh, chair of microbiology at UBC for many years. He was president of Biogen for a while in the 80s.
Wow.
He was foundational to our understanding of how antibiotic resistance occurs, where it comes from, and just a tremendous bon vivant. Like, he's a tiny little Welsh guy, and continuously excited about science, well up into his late 80s. He's just
That's awesome.
full of energy. I loved talking with him. I loved interacting with him. He was just so much fun to be around, and he knew everything, because he'd been around since the 50s. It's just throughout the whole sort of trajectory of antibiotics and antibiotic resistance. So generous with his time and advice and everything. So those three guys would be a really fun hang, I think.
No, that's awesome. I
Yeah.
appreciate you sharing that. That's really cool. Jerry, I just want to say thank you again for making the time today to share your story. You've done so much for not just McMaster, but on a global level for AMR, inspiring hundreds of individuals like John to get in and stay and impact this field, and many others. So thanks so much for sharing your story, for being on the podcast today. I really appreciate it.
Yeah, you bet, Chris. Thanks for having me. It's been a lot of fun.
Yeah, my pleasure. Okay, we'll chat soon.
Okay, cheers.